All right. Hello, everybody. Welcome to another HEIR meeting. So I'm going to go over the PRs and issues since last month. There were 49 that were merged. Okay, we started off with a bunch of OpenFHE dialect improvements. So we have support for extended basis rotation operations so that you can do extended basis rotation and then some adds and mulls before doing a mod down. I think there's still an in-progress PR for the actual transformations to take advantage of that. That adds the IR. We have support for multiple function return types in the emitter. I think, what was it? Extract slice and insert slice got supported in the emitter. There's better support in configure crypto context. And then on the OpenFHE interpreter, there's support for parallel operations. So that interpreter is a little faster. Okay, on the Latigo dialect, we had been trying to get examples to run against MNIST to run in Latigo, and we had some correctness issues. The main one was, well, okay, wait, I don't see it here. It's okay, it must be somewhere else in this list. But we basically fixed the way that we were configuring the Latigo backend to use the sparse encoding properly. Before it was using the dense encoding, but it wasn't cyclically repeating the data to fill all the slots, and so linear transform was incorrect. So we fixed that, and then we did a bunch of general improvements to the Latigo backend output, removing unnecessary copies, that sort of thing. And now MNIST is working on Latigo, and so we're going to move on to some bigger ML examples to run against Latigo next. Okay, so we have this split pre-processing stuff. I think with this, we had some of this last month, but we've improved it significantly from this month. So now it's moved down from where it was to the LWE level. So we'll look at an LWE encode op and scoop up all of the IR just before that, or all the IR depending on that, into separate functions. And now we have it integrated into the pipeline. So if you compile HEIR, you will see a bunch of extra functions inserted called what was it, like pre-packed helper, and then some hash.
It's guarded by an option though. So you have to enable split pre-processing into the pipeline option.
That's not enabled by default?
It's not, partly because I want to iron out the uses of it first. Okay. So yeah, the option just looks like split pre-processing equals n, and n is the number of return values that you want to accept. So instead of returning each encoded plain text back, that would be hundreds and thousands of them. You group them by saying you want to allow 4 return values, and it'll just greedily chunk them up together based on the scale and type and everything. So yeah, that usage of the end thing is part of why I made it not default, because I don't think it's very intuitive for a user to know a priori how many return values it can accept.
Yeah, I guess the problem was if you put it all in one function, which we found out, it will have 1,000 return values, and most compilers do not support having 1,000 return values. Although I learned that the C++ specification says that you have to support at least 256 return values, but we blew past that.
Probably, I mean, you want to do split pre-processing equals 1, but the problem is you can't do that because some of your plain text will be encoded at different levels, which means that they will be different types, which means that they must exist in different tensors.
I see. So
you need to know a large enough bound that can accommodate that many types that you have, but small enough that your compiler will work.
Okay, so there's still some work to do there. All right, so we've also had a lot of help from Eric on implementing key switch in the compiler. And so now we have, I believe, the lowering for key switch, but no, the analysis of the entities is still in progress. And the main change here to the IR is that polynomial type now has a form attribute that describes whether it's in polynomial or coefficient form or evaluation form. It used to be that the NTT op would go from polynomial to a tensor of values, and now it stays at the polynomial level. So we had a lot of discussion going into that. And then on top of that, we have some primitive root calculation that's done that can be done live. I think we still have to hook that up so that it chooses primitive roots for the NTT ops. But yeah, so there's been a bunch of work on that, and I think there's a pending PR I'll discuss in a bit. On loop support, okay, so on loop support now we have the Halo loop patterns integrated into the IR, so loop support is in there by default. Getting actual rolled kernels into the PR, into the pipeline has a bit more obstacles. The main problem is that we assume everything is like static rotations at this point. So like we can't generate rotation keys without some more detailed analysis of the loop to figure out what keys are needed in the loop. And so there's been I have like a bunch of PRs that have been splitting into smaller pieces that basically improve our kernel generation so that they can support loops and dynamically computed rotation shifts. And then I think in progress is the actual implementation of the kernel. There's still some work to do there on like having an analysis that supports loops. I don't have that yet. And then having, what's the other thing? Supporting things like filtering out zero diagonals, like that still needs some non-trivial support for. But then, okay, so then in debugging some of the ML stuff, I realized that our current debug handler basically at the very low level of the IR inserts a call to an external function after every single op, so that you could like decrypt after every single op. With something like MNIST, even unrolled, it's like way too much stuff going on. So I have a new debug dialect that has a validation op. You can insert that op manually at the high level IR and it will be preserved and then converted to those function calls lower. I think there's still one in progress PR to do the final conversion from the validate op to the function call, but that's almost done. And so that will allow you to say like only do the decryption of the IR at the end of each layer in the ML model instead of having it after every single rotation op or whatever. So that, thanks to Edward for that idea. I think that will become very useful. Okay, we have a bunch of tech debt. So we realized that the application data attribute is not being used on LWE. It was being used in the debug helper, but I refactored the debug helper so it doesn't need it anymore. So that is now gone. We have finally migrated off of the old workspace style of using Bazel to using Bazel mod. So now all of our dependencies are in the module Bazel. And then we removed some old TOSA stuff. We had gotten issues from internal saying that TOSA was changing and it was breaking our stuff. And I was like, well, we don't use TOSA. So I just ended up deleting it. And then we had some general improvements. I fixed a bunch of those fuzzer tickets that came in from that academic paper. That was nice. And then we improved, so yeah, we improved the range analysis on the polynomial approximation for MNIST. That improves the model quality. I guess this is good insofar as the things that we think will improve model quality are actually improving model quality, which gives me more confidence in the correctness of the compiler. And then, yeah, there's, yeah, okay, there's just some more cleanup. I tried adding this like agents file. Okay, so sometimes I use the, LLMs and it will invariably use the deprecated form of the like op creation method. It will say rewriter.create and then pass in things, and that's deprecated. And so I was like, okay, I can't get the LLM to learn the new thing because it's too new. So I said, okay, I'll put it in the agents file, and it ignores it. So if anyone knows how to get an actual LLM to listen to what's in the agents file, I would be appreciative because that's annoying. But yeah, so I was thinking stupid stuff like that. Like it always looks for build.bazel instead of just build, right? Even though both are valid in Bazel. And so then it will get stuck in a loop saying like, maybe build.bazel is in this directory. Maybe build.bazel is in this directory. And I'm just like, no. Okay, so stupid stuff like that I think belongs in agents MD, but I can't get it to listen to it. Okay. Notable new issues. So we had a user with encountering a duplicate OpenMP runtime. So this will happen if you are compiling on a system that has multiple OpenMPs installed, and it will sometimes just one step of the pipeline, it will link with one OpenMP runtime and another step link with another one. I have been thinking about doing a hermetic LVM tool chain so that like Bazel would manage its compiler and all of its sources, but turns out every hermetic LLVM toolchain out there does not support OpenMP. So I have to myself add OpenMP support to one of these things if we want to do that. I also have been getting so sick of OpenMP, I asked the OpenFHE developers if they would consider switching to something that's not OpenMP. Like the C++ standard has multi-threading in it now, and there's like lots of other libraries out there that you could use that are maintained and modern. And anyway, but I haven't heard back about that yet. Yeah, the Python build is still failing, sadly. Also partly because of OpenFHE's build complexity. I haven't had a chance to get back to it. But every month it tries, and when it fails, it creates an issue for it. So that's why it's in the list. Yeah, okay, moving here to a hermetic C++ toolchain. If you're interested in that, click on the link. There's lots of details there. We updated Latigo in order to get some new feature that Latigo 6.2 had.
Right.
Oh no, we didn't update it. We want to update it because they fixed their thread parallelism, right?
Yeah, so like before you had to like shallow copy all your evaluators or keys, and now it's fine. So now we can do high level parallelism.
That's right. And we noticed that the biggest performance improvement for OpenFHE was just having lots of threads and letting it do multi-threading for its implementation of various things. And so we're thinking, okay, why not also do that with Latigo and run Latigo like at our compiler level, find all the parallel things and spawn some Go routines or whatever it is in Golang. But it looks like we need upgrading to 6.2 to do that well, maybe. Okay, so I started working on upstreaming key mem RT, that paper, to HEIR. I haven't got around to like cleaning up some of the comments on the initial PR. But this is a research project to do like memory management for keys so that you can store your keys on disk, give it the latency of how long it takes to get from disk to memory, and then insert like prefetch commands that will have it load the key from memory just before it needs it. So that's pretty cool. And I think it will be useful a lot for accelerators because the same idea happens to getting memory onto the accelerator that when it's needed for some operation, or between like, between HBM and like a chips memory, that sort of thing. Okay, there's oh yeah, I think Cindy gave a paper about a new softmax formulation. She is getting into the front-end torch improvements, and so she's running into ops that we need to have kernels for. And so we're going to look into that. Yes, there's been a lot of discussion about getting a fetuslib backend into HEIR. I think, yeah, we have 2 issues now for this, but we've been having meetings and sending emails back and forth. So I think a fetuslib backend is coming. A basic one is coming soon.
Yeah, I mean, probably your PR that you'll probably have lots of comments about how I try to make it work in Bazel.
Okay, all right. Yeah, GPU in Bazel is not something I'm super familiar with, so it should be fun.
Yeah, me neither, so that'll be
okay. I'll help you with that. Yeah, and then okay, 3 issues about fetuslib. Okay, because the third one is there was a researcher.
I think our script that does the export doesn't understand what a sub issue is because those are just the 2 sub issues for the.
Okay, yeah. One of the goals, I guess, with GPU backends is to do kernel fusion in the compiler for like a whole program. So that was what some of the grad students involved in this are interested in. And then we are still working on having the Konami backend being upstreamed. Okay, I think I'm going to speed through some of these issues. I think these are issues that are all in the implementation of key switch. So I think a lot of these are follow-ups from Eric's PRs. Let's see, we have. Yeah, what are these issues? Okay, I don't know.
Honestly,
how
they're these are just like code health, like little nits and stuff. There's really nothing interesting there.
Yeah.
To be honest, like they're mostly Fallout issues.
Yeah. Okay. Little cleanup issues that we filed as we're working on other stuff. And then, okay, so this is the loop support. As I said, there's this option to keep lineage kernels rolled. I put that as a placeholder because I've been working on it without an issue attached. But then so loop support is incompatible with the ILP for optimizing relin, doing lazy relin. So I think what I'll ultimately do is have this work on like an individual basic block, which is like the innermost basic block of loop nest, and then I can reinstate it. And then, yeah, the analyzing rotation keys, I mentioned that. Yeah, there's some bugs that got filed this morning. I haven't had a chance to read them. Latigo's alloc to in place pass doesn't quite seem to be correct. I think we had some issues with it, and then we disabled it because we weren't sure how to fix it. There was some scaling.
No, actually, that maybe is at least one of the problems is fixed there. There was an issue where alloc to in place. At least I fixed the part where alloc to in place uses storage from something with a different level. So now it sorts and only chooses storage that matches the level of the ciphertext it's allocating to. So at least that problem is fixed. Maybe there's more.
Yep. Yeah, I guess that the Latigo in place stuff is weird because it asks you to find a pre-allocated ciphertext or plain text that you can use for the op. And if that one is configured at the wrong level, then it will crash or give you incorrect values. I forget. Okay. And then, yeah, okay, someone filed this PR about emitting an FHE manifest. I didn't understand what they were talking about. So, I added a comment asking for clarification and haven't heard back. Okay, in progress PRs. So there's a big PR with Kornami's dialects and backends that I'm slowly going through. Apologies, it's you know, I have a lot of feedback and it's taking time to go through it all. I think it was 10,000 lines of code. So I have been working on having a target specific table gen config so that we can say we have Latigo backend as like one, or like, you know, when we say to Latigo or annotate the IR with Latigo backend, then we can have it load static configuration that gives all the information about, you know, like we haven't got there yet, but we want to have like, you know, op profiles, like relative costs of add versus mul versus bootstrap and key switch and stuff. And then have any other constraints associated with the backend. And I think we want to do this in a way that's like generic for all the backends, and then like expose an interface for the passes that need it for particular optimizations. I think the right way to do this is table gen. And I just I was experimenting with having like a basic config that we could integrate into the pipeline and then expand from there. I haven't had a chance to work on it too much, but every time we talk about different optimization passes with contributors, they're like, oh, and we can have a cost model. And I was like, yes, we should have a cost model. But our cost models are all just like hard coded in the code right now, and we want them to learn from data. Okay, and then this is, I think this one is the optimization pass that does the greedy hoisting of operations into the extended basis. That's nice. I thought that was done, but I think we just haven't, there's like a rebase and merge conflict. Yeah, okay, this is the fix for the in-place transform. And then this is my work on keeping the first kernel, which is the like baby step, giant step kernel, keeping that rolled. I'm splitting off from that PR into a bunch of smaller PRs. This is the keymem runtime dialect. Okay, this is okay. So this is a good one. This is Edward Chen's work from I think it's the first version, first pass, initial version, or it's not like a full Rotom, or what was it? Not Rotom, the other one. Orbit. Sorry, yeah, I can't remember. It's like the Orbit ILP solver. It's like the minimal working version of that being upstreamed so that we can get a smarter bootstrapping placement pass. So I think that one is probably ready for a second round of review soon. And then
one more day on that, but yes.
One more day, yeah, that's fine. No rush. I've got plenty to do. And then this one is another solver that has an open PR. This was Eric's work on key switch, and then once the key switch is lowered, he has this pass that does optimal INTT and NTT insertion, so that it minimizes the total number of NTTs, but it does it with a constraint satisfaction solver. So that's very fun. And thankfully, we already have OR tools integrated, so he just uses the OR tools CPSAT solver. So that one's nice. I hope we get that in soon. Okay, this is the debug validator that I mentioned earlier. This is my PR trying to use the hermetic LLVM toolchain. It's a very small change, but it has a bunch of build breakages. So I'm like, oh, it would be so easy if only. Okay, yeah, okay, we had that issue for that earlier. So this one, we had a community contributor who added the like default debug handler, so that like you don't have to write your own debug handler anymore if you want just like basic debugging information. And then this PR is an end-to-end test that actually uses it. This is one of my PRs. Yeah, okay, all of these PRs are just like little pieces of supporting rolled kernels. And then this is brand new as of this morning. I don't know what this one is. I think this is Oscar's work.
That's me
average
debugging
pooling.
Layer doesn't work.
Yeah, I think Oscar found a bug in the way we're doing average pooling, and so this is fixing that. Okay. Open topics. So I don't think I have any open topics, but I believe I don't want to put Edward on the spot, but I think Edward mentioned he wanted to talk about parameter selection, or I may have volunteered him last week to talk about parameter selection during this meeting. If you aren't ready, you can say no, that's fine. We can talk about other topics, but yeah, okay.
I updated the Google Doc on this, so I'm happy to share this, but it is like an open research project that I'm like looking into next. The high level idea here is we have a couple of different systems in-house at CMU for both layout assignment, bootstrap placement, and scale placement, as well as like a GPU backend. And we kind of want to use HEIR as like the middleware to connect everything together. So in the Google Doc, if you like look in the overview, it basically links all these different systems and papers. There's two main goals that we want to do. The first one is correctness. So given any sort of ML model and some sort of FHE scheme, we want to basically be able to approximate the error and guarantee that when you decrypt the inference result, you get an actual correct result. And the second part here is performance. So we want to be able to optimize all of your different parameters such that you get your peak performance. It's really naively simple to get correctness if you just set very high parameters. So if you're setting the scales to all be like within the range of like 40s to like 60 bits, this is really trivially done. However, like as we've seen with both Orbit, like by recent preprint, as well as like Da Capo, you can actually tweak these scales to be much lower to get better performance. The lower you get these scales, the less essentially like scale capacity you're using, which then saves on levels and then saves on bootstraps. And that's kind of like the key point here. There are also a few other like facets that we want to consider as well. So aside from just the cryptographic parameters, we also want to set certain hardware constraints. So if you're constrained by memory, or if you want to tackle like different latencies, like that is like another thing that we want to optimize for as well. One example of this is like when we're looking at scaling up a program to support something like Llama 7B, you're going to be having like in the terabyte ranges of like plain text weights. So like what's the best way of encoding that, and are there like other compression techniques in order to solve that? The main approach here, I think like the current naive approach here is like, if we are given some ML model, we want to basically figure out what are the constraints for every single layer in order to determine the accuracy of running this ML, secure ML inference. And a naive approach is essentially like you run this in the plain text a bunch of different times, and you figure out the range of values each layer is acceptable in taking. And with this information, you can then build a set of constraints that your FHE compiler pipeline can then go ahead and optimize over. That's kind of like the simple way of doing this, but also you then have to like run your model many, many times in the plain text. So I've been looking at other things as well in the realm of ML robustness. So I feel like there are tools that exist here where you can basically test your ML model end to end by giving it some perturbation in terms of its input error. And I think a core idea here that hasn't been explored yet is essentially, can we do this at the per layer level? And can we actually figure out the inverse of this equation, which is the current equation is you have some sort of activation function or layer, and you give it some error, and it gives you back the accuracy. But can we do the inverse, which is like you give some activation function and you want some threshold accuracy, and it tells you how much error you can get. And with this information, we can then define all of our different ranges for each of our different layers. And again, this goes back to like, okay, how do we then like tune our scales, and how do we then play with like bootstrap placement, level placement, scale placement, and etc. Yeah. So yeah, if anyone has ideas on this, this is like really new. I'm like looking into this now. this is going to be built on top of the existing pipeline that we're also trying to integrate into HEIR.
Very nice. Any other topics that people want to share, or questions or issues?
Maybe a question to Edward, right, which is a bit provocative, which is, what would it take in terms of, cleaning up, improving whatever HEIR to make you write the next paper directly in a, private whatever for HEIR, rather than a separate thing that we then port?
Oh, well, I think this project will be built into HEIR. At least that's like my current plan. The idea is basically we have our layout assignment and bootstrapping systems already. So the layout assignment already just sits as a front end, and I think HEIR also has its own front end. So I don't want to like integrate the two of them together. But the bootstrap placement, that's like what the latest PR is for sure, adding a bootstrap placement and stuff. This new project would just be more of like a, hey, how do you test these plain text models and give it a set of constraints? But the optimization passes will all sit within HEIR. So yeah, this should be built directly into HEIR. And then
that's a perfect answer to that question. But I assume there's more people.
Yeah, tomorrow when you like talk to Sid and Demetrios as well, I think part of it will also be trying to convince them like, hey, yes, we would want GPU support and kernel fusion support in HEIR, and figuring out how to do that.
Yes. I mean, we will be having some GPU support with some basic physlib backend, but there is lots of issues with that, both from a maintainability perspective. Physlib is not like, it's a kind of tied deeply into OpenFHE and things like that. And I think actually the GPU library support is really, for me, a motivation for the kind of research you just mentioned, right? Cranking a PyTorch model through a working FHE circuit is really easy if you do it for one backend and you hard code all the assumptions about how the noise management works in that backend, right? It's a lot harder to then take something that assumes a certain backend and make it work for other backends, as I think Jeremy and Ezra have been finding out firsthand, and I'm starting to find out. And so I think having really good generic ways to do this problem, to solve this problem, is really important, because as we're seeing a proliferation in GPU libraries, right? It used to be that if you supported OpenFHE and Latigo, you supported all FHE libraries. This is really not going to be true for the next couple of years as we figure out what the winning strategy on GPU looks like. And so I think, yeah, having the ability to actually find these out for the backend would be really important for us, because it's lovely if HEIR produces code, but it only matters if the code runs and produces a valid output, right? And right now, the backend that will run something, but it's very hard to make the higher level parts generate code that expect that backend.
Yeah, I think it might be worth just also giving some context for everyone else and folks who may be watching on YouTube about the discussions we've been having about GPU. So right now, we don't have any GPU backends working in HEIR. But we've had lots of interest from different people making GPU backends to integrate with HEIR. I think Cerium is one of them from CMU, FetusLib, and then the Desilo backend is another one. And so we've been having conversations with all three of these groups to figure out what to do. And I think with FetusLib, at least, I mean, there's sort of like different layers at which we can integrate. So there's one layer where we take our current OpenFHE output, and then we just say, okay, change some of the code gen, and you get a FetusLib backend. So that is, in theory, going to work, but we'll have like two problems. The first problem is that it won't have explicit memory management, and so it will probably be slower for that. The second problem is that FetusLib and OpenFHE as well have higher level APIs that we are bypassing to implement our own kernels. So for example, I mean, the two are Linear Transform and Chebyshev. And so there are like, a special GPU implementation of those that we will be skipping. And so one thing we can do is preserve those from the higher level, just make sure they're packed appropriately, and then emit calls against those APIs. So that I think would get back a lot of the performance gaps because the fetus lib kernel or whatever the GPU kernel would be handling the memory movement within that implementation of that linear transform up. Fine. And for folks who want to be GPU FHE library developers, right? Like the fetus lib folks seem to have that opinion. Or maybe I think there are a couple of companies who are saying like, basically our company's secret sauce is we have a fast GPU implementation and it requires the library API. So for these folks, I think it makes the most sense for us to just output calls against their library API. And the thing that we lose from that is we can't do program-wide kernel fusion or scheduling that happens within the kernel, basically below the kernel level. And so I think Cerium is probably the only example of a GPU backend that we have that folks want to be doing kernel fusion. And then we have some grad students who saw fetus lib and said, oh, who aren't like directly involved with fetus lib, but they saw it and they said, oh, we want to do kernel fusion. So it's unclear to me like how exactly that will shake out. It will probably, like, I doubt we will have like the fetus lib code upstreamed in any way, but if you want to do kernel fusion on like with fetus lib, you would need to have basically the FHE kernels implemented in HEIR somewhere. And I think there's also like, I think one of the big things that is like an unknown to me is if there's going to be a bunch of GPU specific stuff in the compiler. Upstream MLIR has a lot of GPU specific stuff, and there's so much prior art with like the HEIR project where they have like this like flow dialect that manages memory on GPU. So like there's all this stuff that I haven't looked into because I don't do GPUs that I think we could use to like jump start like a HEIR native GPU kernel fusion type thing. But it's just like a big open question for me because I don't do GPU stuff, so I'm not super familiar with it. But so that's like the status that we're at with GPU support. And I agree that I think one of the huge challenges is if we are getting something to work for one backend, getting it to work for another backend is really hard. And I think GPUs will definitely compound that issue. And I guess the other thing is that just like for full transparency, I don't think Google is going to be in the business of running GPU FHE on GPUs in the near future. For security reasons, we can't take some open source implementation of cryptography and use it without like extensive security auditing, and it's not worth it. And so instead, what we're doing is we're having our in-house TPU backend, and we're planning to use that for like our first big deployments whenever those may happen. But yeah, so in the same time as all of this stuff is going to be happening with GPU, we are going to be upstreaming. We have some grad students who have, I think, already built this, and we just have to upstream it. Code generation for the TPU implementation of CKKS, and then we have some like TPU aware optimization passes that we want to put in there as well. So yeah, TPU support is also happening. TV. But yeah, so that's where we're at. Any other topics people want to discuss? Let's see who's in the meeting. Got Eamon and Mark. Okay. All right. Well, yeah, I don't know. Anyone else or?
I guess I
Okay,
have
we can end early, but yeah, go ahead.
For Eamon maybe. So for like the rotation keys, are you prefetching like from disk like during inference time?
Yeah.
And then would you also do the same for like plain text encoded weights and stuff? If you're
I mean, you could do that, and I think nothing prevents you from doing that. But I mean, KMRT is not focused on plain text, so.
Okay, I see.
Yeah.
So you're saying for like Llama 7 billion, you don't,
Yeah.
we've got a terabyte of disk, but not a terabyte of RAM.
Well, I think there's just like a question here that I don't know if you know the answer to, but like the cost of encoding paid by compute, so like encoding on the fly versus the cost of fetching from disk. And I think like at least from Sid's experiments, the cost of fetching from disk takes like 20 minutes to load all of the plaintext weights and stuff. But if you like encode on the fly, I think it's faster. And then the inference itself is within 5 minutes. So fetching from disk may or may not be the most performant, but I think it is definitely like a usable solution.
Yeah. So to be honest, like the load keys say there is this load keys API, but the dialect representation of it, but it just means that we need the key now. And it doesn't really mean we have to materialize it somehow through the disk. So it can mean, for example, we can re-encode it now again. It can mean that, or it can mean, for example, in the case of rotation keys, we can make it mean that we can generate a rotation key from another rotation key, like in the hierarchical rotation key paper. So it just means it is the infrastructure basically to provide the IR and the materializer, but the backend can change, I think, and it's really platform dependent. Yeah.
I wonder if we should like generalize that as I upstream it to support stuff like materializing any other data, right? I mean, I kind of had that question was like, okay, this is like a generic get my data in the right place at the right time dialect that happens to be specialized to rotation key or key material in general. But I like the idea of having something that could be also used for like fetching encoded plain texts, because I think we had the same problem that like even with small ML models, right, there's a lot of plain texts, and you know, where are they coming from? Are you just gonna pump up memory until you can fit them all in? It's like not sustainable.
Yeah, and to be fair, I mean the rotation keys are really tied to the rotations, and it's kind of a nice problem in FHE, and it's a general problem as well. I think it's FHE is suffering from this, like the number of keys and the memory problems it causes. So plain text is of course like an important thing, but I guess more like a ML specific optimization. Whereas like the rotation keys are inherently like a problem for the batched schemes, in my opinion.
Edward, when you said you've been experimenting, or Sid has been experimenting with, I assume that's on GPU, right? With the recomputing being faster?
Yes, that's on GPU.
Because I was going to say, I think this is a pattern happening that as soon as you go off CPU and onto devices, be it, you know, ASICs or
Different
GPUs,
performance models. Yeah.
Really, like PCIe is just too damn slow. Even the like NVLink things are just way too slow. And so really recomputing, like I think like the twiddle factors is like the smallest micro example that comes to mind. Like everybody recomputes them, I think, on device rather than, whereas on CPU, I'm pretty sure you still want to pre-compute them, right? And so this is like a thing where maybe as we're discussing how to support in like the entire stack of HEIR to not just GPUs, but I don't know, heck, this might even be true for GPU, right? I don't know. But like we might need certain toggles or cost models, right? That let us decide whether we're doing pre-computings or on-the-fly computations and things like that. We can, I guess this is probably at this level, it's probably easy enough to do that, like we enter the exit dialect level or something, but I'm sure it will be only a quick matter of time before we run into something that we want to do higher up the stack.
It's funny that you mentioned cost models, because that's like very tangentially related, if not just should be integrated into this parameter selection project. Yeah.
Yes, I love you mentioned that, right? Like hardware constraints, are we memory or compute bound, right? And I think we are already seeing that there's a fairly significant CPU versus like something plugged into that isn't the CPU shift. And I think I think even at the point of like, what machine learning like kernel do I use, right? Like what do I use to do a map model? That might change depending on backend, and that's like a very high up in the stack decision at the moment.
Right, and we don't have, like, we have some plans for improved layout selection stuff, but yeah, it's going to need some kind of cost model. So I think like at least for Edward, for your work, if you know what things you need in your cost model, right? If you can write those down somewhere, then like I can incorporate them into that PR I have where I'm working on like integrating, having the availability of a cost model for a particular backend into like any pass. Because that's what I want. I want it to be able so you can like just say like, okay, I need this cost model, and then we'll go get you the cost model you need. That's like populated by the rest of the pipeline. So, but I need to know what, like, I think right now I just have like cost of a rotation, like kind of boring.
Yeah, I think the things that I've explored so far have just been like operation costs.
Mhm.
And then it turns out like, depending on how you do your layout assignment and packing, there could be like repeated patterns within your layouts, and that can result in just being able to compress the plain text, which then affects like your memory costs. So I think this is something that I still need to explore as well, because my cost models that I've used in the past have been pretty basic.
All right.
Yeah.
If there's no other topics, going once, going twice. All right. These meetings are getting shorter and shorter. Everyone knows what they're doing. That's good. Okay. All right. Well, I will see you guys all next month. Bye.
See.
See you. Thank you.
How do I stop the recording?